So far, we learned that the permutation or the ordering or arrangement of n objects is denoted by n factorial, which we define this as 1 times 2 times 3 and the rest of the multiplication, and we're going to stop at n. Just note that there are some conventions. 0 factorial is always 1. Remember this. 1 factorial is always 1. Very good. Now I expect you to ask, what if I have a combination of different objects? For example, I have blue, brown, red, orange, and yellow, and green candies. In how many ways I can select 2 of the candies out of the pool and arrange them? So now the question is the number of ordering of our objects taken from n objects is denoted by P of R objects out of n objects. This is defined as n factorial divided by n minus r factorial. Note that your r is smaller than n. In this case, you have 1, 2, 3, 4, 5, 6. So n is 6, and you want to know in how many ways you can select 2 candies and arrange them. So the number of orderings of our objects taken from n objects is denoted by P of r out of n, which is defined as n factorial over n minus r factorial. Suppose we want to do some computations. How do I simplify a permutations like this? The permutation of R object out of an object. For example, suppose I ask you to compute the following. The very first one says, well, here you have permutation of one object taken out of one collection. The collection has only one member. So in a word, if you want to try to visualize this, you have a set including just one member. N is 1. It means that you have one member, and you're trying to select one member out of this and put it in order. Well, you might say that, hey, it's easy to compute. Take a look. By definition, this is 1 factorial divided by 1 minus 1 factorial, or 1 factorial divided by 0 factorial. By definition, 1 factorial is always 1. 0 factorial is also 1. 1 divided by 1 is 1. There is only one way. I select this candy and put it in order. There is no order for this. This is just one element, one object. So taking one element out of one object, you only have one way to order it. Let's make it more interesting. Suppose now I ask you to select one object out of 2 objects. Now here you have a set with 2 candies in it. In how many ways I can select 1 candy out of 2 and write it in order? So let's take a look at this. N is 2 and R is 1. All right. So you have 2 factorial because N is 2 divided by N is 2, R is 1, 2 minus 1 factorial. So you have 2 factorial divided by 1 factorial. 2 factorial, remember that we define factorial this way: 1 times 2 divided by 1, or 2 over 1, or just 2. Very good. These are nice numbers. They're easy to compute. Let us make it more interesting for you. Suppose I ask you to find the permutation or the number of orderings of 4 objects taken out of 6 objects. Perfect. So my N is 6, my R is 4. Following the formula N factorial, 6 factorial divided by 6 minus R, which is 4. 6 minus 4 factorial. So I have 6 factorial divided by 2 factorial, or I have 6 times 5 times 4 times 3 times 2 times 1, or 1 times 2. The order is not important. It's just multiplication. Times 4 times 5 times 6 divided by 2 factorial is 1 times 2. You can cancel out the common factors. What's left? Here you're left with 3 times 4 times 5 times 6, right? So if you do the multiplication, you get 12 times 30, which is 360 different ways. So there are 360 different ways that you can select 4 objects out of 6 objects and put them in order.